Welcome to the deep dive. For the last, 5 years, if you listen to the loudest voices in the AI industry, the mission was simple.
Oh, yeah. Scaling.
Just scaling. Throw enough data, enough money, enough GPUs at the problem, and AGI was, well, it was supposed to be inevitable.
And that initial strategy, what our sources are calling the right turn, was actually founded on a genuine scientific discovery.
Right, the neural scaling laws.
Exactly.
Yeah.
It showed that performance loss scales, predictably with compute. It was a real empirical truth. But now we are witnessing a profound divergence.
It's a hard stop to that dogma.
A very hard stop.
Exactly. So our mission today is to cut through all that noise and figure out why the progress has hit this physical and financial ceiling, a ceiling that's forcing a fundamental strategic shift at the very top of AI leadership.
Yeah.
We're going to explore the consequences of what the source material calls the hard left, this turn that steered the whole field away from efficiency and into a swamp.
The Murray Meadow. It's a great metaphor.
Or a metaphorical swamp of stagnation.
And we really have to define the critical technical failure that's keeping us stuck in that meadow. It's this idea of the incomplete simulation.
Okay.
We'll look at the, frankly, desperate measures being taken to escape the energy crisis that scaling caused, and also, paradoxically, the massive financial and geopolitical machinery that is just fighting tooth and nail to keep the inefficient scaling game running.
Okay, let's unpack that immediately, because the core tension driving this hard left turn, it isn't just technical.
No, not at all.
It's philosophical. It's a clash of fundamental belief systems, almost ethics.
It's a clash between physics and capital.
Explain that.
Well, what's fascinating here is the distinction the sources draw between two disciplines. On one side, you have physics as a truth discipline.
Okay.
Physics doesn't care about market trends or stock prices. It's the search for invariant laws, thermodynamics, information theory, the things that just define what is.
And on the complete other side of that,
You have capitalism as an optimization discipline. This discipline is, well, it's agnostic to truth. It only cares about maximizing advantage, optimizing for profit, for value extraction.
and maintaining scarcity.
Exactly. It sees value not in what's true, but in what can be priced.
So the hard left era was what? The moment one overrode the other.
That's it, precisely. The strategic mistake happened when the optimization discipline of capital just completely overrode the truth discipline of physics. That scaling law was a truth, yes,
A scientific observation.
but industrializing that one observation into a, quote, trillion-dollar dogma while actively ignoring an equally fundamental law of physics.
Diminishing returns.
Diminishing returns. That was the optimization error. The market demanded growth, and the physicists gave them growth through brute force, even when the physics was warning them the engine was sputtering.
That's a powerful indictment. That capital just ignored the physics. But let me push back a bit here. Wasn't that initial right turn incredibly profitable? Couldn't you argue that ignoring diminishing returns was sort of a necessary evil to industrialize the tech and raise the trillions needed to even build the infrastructure we have now?
It was profitable in the short term. Absolutely. No question. It created a whole new market of scarcity, scarce compute. But that philosophical tension, it remains.
Yeah.
You see this cognitive dissonance perfectly captured in what the sources call the quantum CEO.
The quantum CEO.
This is the leader who tries to collapse these two opposed ethics into a single heroic identity. They claim to be a physicist who is also a capitalist.
They're trying to marry two things that are fundamentally opposed. Finding objective, efficient truth versus maximizing a market advantage that actually thrives on inefficiency and scarcity.
And that leads us to the grand irony of the Murray Meadow itself, this swamp of stagnation.
Go on.
I mean, think about it. If AGI truly reached the pasture's green, it would reduce the marginal cost of intelligence to pretty much zero.
Which is an existential crisis for traditional capitalism, right? Where value relies entirely on scarcity.
Exactly.
So the fact that we are stuck in this Murray Meadow, where AI is expensive to train and run, but not fully reliable or effective, that actually, perversely, acts as a safe harbor for the status quo.
It's a perfect safe harbor. The AI is expensive enough to require massive capital investments, which preserves the hierarchy of who controls that capital.
But it's not effective enough to replace all knowledge work.
Right. So it preserves the value of specialized human labor. It sustains the hierarchy by making AI investment high stakes, but prevents the total collapse of labor value that true, efficient AGI would cause.
The meadow is structurally necessary for the current financial system to survive.
It seems that way, yes.
That makes the Mori Meadow sound less like an accident and more like a feature of the current market. But let's zoom in on the technical side of being stuck.
Okay.
If the clash of physics versus capital is the why we're stuck, the technical reality of the incomplete simulation is the what. What is actually failing inside the machine?
Well, we need to be really clear about this failure. Current large language models are probabilistic engines. They are magnificent statistical tools
Sure.
that predict the next token based on likelihood. They capture the mimesis, the appearance of reasoning. But they fundamentally lack the causal physics,
The generative rules.
the generative rules of the domain they are simulating. They're simulating the result of understanding, not the understanding itself.
And if the model doesn't grasp the underlying physics, you get what's called the robustness gap.
Exactly. It's incredibly brittle. When the environment or the data distribution shifts even a little bit,
Yeah.
the model can't adapt organically. It panics.
And it requires a complete, incredibly expensive retraining cycle.
Right. The source material has this great kind of terrifying illustration of this, the bug loop.
The bug loop.
Imagine a cutting-edge coding model. It's tasked with writing software. It introduces a bug. Then, in the next iteration, it fixes the bug.
Okay, sounds good so far.
But then it reintroduces the exact same bug later, trapped in this endless cycle. It's not behaving like a clever software engineer.
It's acting like a simple statistical engine.
A Markov chain, trapped in a local optimum, doomed to repeat its statistical errors forever.
Wait, so the bug loop means the AI looks competent, but it's just repeating statistical errors infinitely. That sounds terrifying for any high-stakes, real-world deployment.
Like in diagnosing patients.
Or managing critical infrastructure. The failure is fundamental. It's a lack of comprehension.
And that lack of comprehension is where the thermodynamics come into play. The financial constraints we see are, in a way, thermodynamic. The current brute force architecture compensates for its inherent lack of deep understanding with sheer, massive, energy-inefficient scale.
Because they don't get the concepts efficiently, they have to overcompensate by using hyper-accurate, high-precision math FP16 to model concepts that, if they just understood the structure, wouldn't require so much compute.
It's the definition of waste.
Total waste.
Absolutely. The energy wall is the physical manifestation of the scaling game's failure. It is simply unsustainable to keep throwing FP16 matrix multiplications at the problem. We've hit the point where the cost of finding the next tiny performance gain is just astronomical.
This realization has led to some desperate innovation. Let's talk about the one-bit LLMs.
BitNet B 1.58.
Right. This is more than just a clever optimization. It feels like a massive technical admission that the age of FP16 brute force scaling is hitting a dead end.
It truly signals a fundamental pivot in the computation paradigm. Instead of high-precision math, these models quantize their weights down to just 3 integer values, -1, 0, or 1.
So simple integer addition instead of complex floating point multiplication.
And energy savings are just staggering. The sources quote something like 71.4 times less energy required, plus 8 to 10 times compression. It's a forced march toward efficiency.
Dictated by physics.
Yes.
When you see a leader like Ilya Sutskever, one of the foundational architects of the scaling era, walk away from OpenAI, you know the writing is on the wall.
This is the Sutskever pivot, a deliberate strategic shift back to research mode.
It's an explicit reaction to the limits we've just been talking about.
For sure. And the schism in leadership, it really highlights the 2 eras of modern AI development, according to the sources. You had the age of research, roughly 2012 to 2020.
Right.
The main driver there was architectural insight. Breakthroughs like AlexNet or the Transformer. They required relatively low resources, maybe 2 to 8 GPUs.
The success metric was just pure insight.
It was insight. Then came the hard left and the age of scaling, 2020 to 2025. This era demands extreme resource intensity. We're talking 10K to 100K H100 clusters.
And the success metric got reduced to just watching a loss curve drop.
Dropping according to the power law. Sutskever recognizes this area is now creatively bankrupt. He is trying to preempt the chasm of disappointment.
It's a market correction.
The inevitable market correction when the hype around these trillion-dollar valuations finally smacks into the failed utility and cost of the incomplete simulation products they're shipping.
So his new company, SSI, or Safe Superintelligence, it seems to be explicitly avoiding what the sources call the product trap.
A product trap, yeah.
Companies like OpenAI and Google, they're forced to ship incremental products, even if they're flawed, just to justify their massive valuations.
Whereas SSI, by refusing to release incremental products, is buying time. the time to do the really hard foundational research required to fix that underlying simulation failure.
Their strategy is focused on unhobbling the models. It's not about finding more data, which is just scaling dogma in disguise.
It's about returning to physics as a truth discipline, seeking out the deep principles that create efficient understanding.
Which means finding the biological priors.
Exactly.
The hard-coded structural knowledge that lets humans learn with this incredible efficiency. I mean, think about the generalization gap.
Yeah.
A human learns to drive in, 20 hours? An AI needs billions of equivalent frames of data. The goal of this pivot is to find that missing structural knowledge to bridge that chasm.
And if they succeed, they shatter the energy wall, not with brute force, but with architectural efficiency.
That is a fundamentally rational response to physical and financial limits. But here is the profound paradox. While the technical vanguard is pivoting and basically admitting defeat in the scaling game, the market remains exuberant.
Wildly so.
The financial machinery just continues to fund the dogma. How is that possible?
It's sustained by these really powerful structural forces, and the main one is the NVIDIA distortion field. NVIDIA has effectively become the central bank of the AI economy. It's created a circular, closed financial flow that completely masks the technical stagnation and the lack of real economic utility.
Let's break down that circular flow, because it's key. The sources describe a vendor financing model. NVIDIA invests billions in equity directly into its biggest customers, the AI labs, the cloud providers.
Who then take that money
and are essentially required to use it to buy more NVIDIA chips. It is a brilliant closed loop. It's genius. And means that the high valuations for these AI companies are sustained based on the input, the amount of scarce compute they're buying, rather than the output.
The measurable economic utility, the actual breakthroughs.
The market is valuing the industrial activity of building the clusters, not the quality of the intelligence being produced.
And just when private capital might start to question this circular logic, the state steps in. The market is insulated by a massive geopolitical backstop.
The AI sovereignty narrative.
Yes, that narrative has led governments all over the world to fund national clouds or continent-sized clusters.
This is a critical mechanism. By explicitly linking AI development to national security to the technological race, often citing competition with China.
Governments justify infinite spending on these expensive, incomplete simulations. The government becomes the buyer of last resort for the scaling dogma.
Which effectively decouples the spending from economic reality.
And this is why, despite the trillions poured into the AI industrial complex, we see stagnation in the real economy, the productivity paradox.
The sectors that require high trust, complete simulations, like, specialized healthcare, complex legal work, education, they're all resistant to automation because the AI models are incomplete.
The intelligence being produced is failing on two fronts. It's not cheap, because of the energy and FP16 costs, and it's not reliable because of the robustness gap and the incompleteness of the simulation.
And without both cheapness and reliability, the economic transformation promised by AGI just remains perpetually stuck in the meadow.
Forever, it seems.
So, if the physics wall is unbreakable and the market is structurally incentivized to keep funding inefficiency, what is the market's escape hatch? What's the Deus ex machina it's banking on?
The sources suggest it's the speculative promise of quantum AI. Quantum AI is increasingly positioned as the market's speculative fever dream. It's the exit strategy from the meadow. The promise is that quantum interconnects and solvers could, theoretically, bypass the energy limits of classical matrix multiplication.
Shattering that energy wall instantly.
Potentially. We're talking about highly specific, speculative applications, like using quantum optimization for hyperparameter tuning.
Which would make the training process inherently more efficient, even if the underlying model stayed statistical.
Exactly. The growing discourse around quantum integration really represents the desperate hope that a simple code commit could unlock a hardware revolution.
So if quantum AI makes running incomplete simulations infinitely cheap,
it re-energizes the capitalist optimization machine and delays the final reckoning with the physics truth indefinitely.
So as we wrap this up, the current moment is defined by this massive divergence. On one hand, you have the research pivot, led by technical experts seeking efficiency and physical truth. And on the other, you have the market momentum, led by capital and geopolitical narratives, just pushing scale and optimization, completely ignoring the physics warnings.
But that hard left was a strategic error. It was born from mistaking a mere empirical scaling law for a law of nature. The core challenge now is recognizing that the future belongs not to the one who can build the biggest cluster.
But to the one who can find the efficient, structurally sound path out of the swamp.
That's it.
We've established that the path to true AGI is currently blocked by physical and energy laws, and the market is structurally incentivized through these geopolitical and financial loops to keep funding inefficient scaling. So we'll leave you with this final thought to mull over.
Okay.
If the internal technical and financial logic is broken, what external shock, be it a sudden radical technical breakthrough that's unrelated to scaling or a geopolitical destabilization, what shock will ultimately be required to force the industry back onto the correct path to physics truth? We'll see you next time on The Deep Dive.